All right, so this is part 2 of 6.6. So 6.6, this is the last problem that we did. And so we're going to talk about a couple of theorems here in part 2. So let's go ahead and start with the first one, which is called the remainder theorem. Okay, so the remainder theorem. Again, this is still 6.6. Okay, so here this states that if a polynomial, and we'll call it p of x. Okay, so if a polynomial p is divided by x minus k, all right, which is what we were doing with our synthetic division. So if you're dividing one polynomial by x minus k, the remainder is actually equivalent to p of k. Okay, so here's the k over here, right? So here, let's go ahead and set it up. So like when you do this, right? So if you're dividing by x minus k, then over here we would have xk, right? And then over here you would have your polynomials, and then you would do your synthetic division, right? And you get numbers over here, and then you get a number right here. Let's call it c, okay? Which is our remainder, right? So what they're saying is that if you evaluate p at k, so in other words, if you plug k in for x, work it all out, you're going to get this c value here, this remainder. So that's kind of neat. So what they're saying is that this synthetic division is just another way to evaluate polynomials, because this remainder here will be equivalent to evaluating the polynomial at this k value. Okay? All right, so let's take a look. So that's kind of a neat little theorem. Okay, so let's recall when you had something like this. F of x equals 2x squared minus 3x plus 1. And then oftentimes they'll say, okay, so there's your function. Go ahead and find f of 1, right? And so way back when you were in kindergarten, right, you would take that 1 and plug it into the function, right? So you would go ahead and say, okay, well, f of 1, replace all the x's with 1. So you would go ahead and do this, work it all out, 2 times 1, doing your order of operations, right? And you would work this all out. Zero. Okay. All right, so f of 1, so when you plug in 1, you get 0. Okay, so what they're saying now is that, oh, if you want to find out what f of 1 is, you can just do synthetic division. You can just do synthetic division for x equals 1 on this polynomial. So 2, negative 3, 1. 2, negative 3, 1. And so let's go ahead and do that. 2 times 1 is 2. Negative 3 and 2 is negative 1. Negative 1 times 1 is negative 1, and we get 0. So here, this remainder would be your answer. So you can just say, oh, okay, f of 1 equals 0. Okay. And so I can also do this for any number. So if this is my function, right? If this is my function, I'm wondering, oh, I wonder what I get if I plug in 3. Well, you can do x equals 3 on that function, 2, negative 3, 1, and just do your synthetic division. 2 times 3 is 6, 6 minus 3 is 3, 3 times 3 is 9, 10. So right there, f of 3, when you plug in 3, you're going to get 10. Okay? If you want to know what you're going to get in this function, if you plug in, let's do -2. Okay? Let's do -2. So x equals -2. We want to know, what do we get when we plug in -2? 2, -3, 1. Okay, bring this down. 2 times -2 is -4. -7, you get 8. Combine them, and you get 9. So f of -2 is going to equal 9. Okay, you see how that works? Okay, so normally on the test, I would say, oh, evaluate this using the remainder theorem. And it's interesting. I'll put this question on a test. Like for you guys, it's all online this semester, so I won't be able to see your work. I won't be able to see if you actually use synthetic division or if you do it the old way. But oftentimes, students will do it this way on the test, and I have to mark them incorrect because I explicitly say use the remainder theorem to evaluate f of 1. Okay? But I don't get to see your work on the test, so that's okay. All right. Okay, try this one just to make sure you understand it. Okay, so p of x equals 2x cubed. This 2x cubed minus 3x squared minus 2x plus 1. Find p of 3 using remainder theorem. Okay, so the method that I just showed you. Okay, so go ahead and hit the pause button, do the work, and come right back, and we'll see how you do. Okay, so x equals 3, 2, -3, -2, 1. 2. 2 times 3 is 6. 6 minus 3 is 3. 3 times 3 is 9. 7, 21, 22. So p of 3 should equal 22. Okay. I like this method a little bit more than I do the old-fashioned method of plugging it all in and working it all out. This just seems so much easier. Okay, so that's the remainder theorem. We have one more theorem, the factor theorem. Remember to message me if you have questions during your viewing of these videos. Okay, if p of x is a polynomial, then p of k equals to 0 if and only if, that's what the IFF stands for, if and only if x minus k is a factor of p of x. Okay, so this is kind of a big deal because so x minus k is a factor, okay, if you get 0 for a remainder, right? That makes sense. Just like with regular numbers, like 5 is a factor of a number if you get a remainder of 0, right? So if you do 10 divided by 5, you get 2 remainder 0, right? So 5 is a factor of 10. If you divide 8 divided by 5, you get 1 remainder 3. Okay, you end up with a remainder. So 5 is not a factor of 8. So same thing here with polynomials. Okay, x minus k will be a factor if you do your synthetic division and you get 0 for a remainder. Okay, if you get 0 for a remainder, then x minus k is a factor. Okay, all right, so let's take a look here. All right, let's let p of x equal 3x cubed minus 5x squared plus 3x minus 10. Show that a p of 2 equals 0, and then also show that b, x minus 2 is a factor of p of x. Okay, so for part A, we're just going to go ahead and do synthetic division to show that we get 0. Okay, so p of 2 equals 0, so we're going to do x equals 2, and we have 3, negative 5, 3, negative 10. So bring this down. 3 times 2 is 6. We get 1. 1 times 2 is 2. We get 5. 5 times 2 is 10. We get 0. Okay. So by the remainder theorem, p of 2 equals 0. Okay. All right, now for part B, show that x minus 2 is a factor of p of x. Okay, before we get into that, you don't have to copy this down, but I want to just show you with numbers. Okay, so if I have this, let's say I have 123 divided by 5, all right? And then if I go off to the side and I do this long division, right? I get 2 times 5, 10, 2, 3, 4, 20, and I get a remainder of 3, right? So what happens is, another way to write this is 123 is going to be equal to 5, the thing you're dividing by, times 24 plus your remainder, which is 3, right? So if you multiply that out at 5 times 24 and then you add 3, you're going to get this 123. So this way of writing 123 is going to be the way that we write our polynomial in part B. Okay, so kind of like, let's see, let's go up to find one that has a remainder in one of the examples. Okay, so like here, right? So here we can say 2x cubed minus 3x squared minus 2x plus 1 is the same as doing x minus 3 times this polynomial right over here. So that's going to be 2x squared plus 3x plus 7, and then plus our remainder, which is 22. So we're going to do the same thing that we're doing with the numbers. Okay. Do you see how we did that? This is our polynomial. That's up here. 2x cubed minus 3x squared minus 2x plus 1, right? And this is what we're dividing by. We're dividing by x minus 3, okay? And this is the answer we got. 2x squared plus 3x plus 7, and plus the remainder, okay? So that's what we're going to be doing here for part B. Okay, so we're going to go ahead and say that this polynomial, where is it? Up here, 3x cubed. 3x cubed minus 5x squared plus 3x minus 10 will be equal to, we divided by x minus 2. And the answer we got was this one down here, degree 2. So 3x squared minus x plus 5 plus our remainder, but our remainder was 0. And then if we simplify that, we get this. And then here we show that, oh, x minus 2 is a factor. Okay, because we don't have a remainder here. Okay, so that's it. That is it for the remainder theorem and the factor theorem. You might get a question that says something like this. Determine, so here, let's do an example here. Determine if the first expression is a factor of the given polynomial. Okay, and so you might have this one, x minus 3. So that's our first expression. And we want to know if this is a factor of this polynomial. And let's do x cubed minus 3x squared plus 5x minus 15. Okay, so to find out if it's a factor, we want to see if we get a 0 remainder. Okay, so 0 remainder means that it is a factor. Okay, so we're going to go ahead and do our synthetic division. 1, negative 3, 5, negative 15. We're going to do our synthetic division here. We get 3, that's 0, that's 0, that's 5. 5 times 3 is 15, that's 0. Okay, so we get 0 remainder here, so our answer is yes. X minus 3 is a factor of p of x. Okay? If you get something other than 0, then no, it's not a factor. Okay? Because you get a remainder. Just like regular numbers, if you end up with a remainder, then we know that that number doesn't go into it evenly, right? Okay, same thing with polynomials. All right, so that is it for part 2, 6.6, but that is it for chapter 6. We are done. Okay? All right, I will see you guys next time.